Oh, hey guys, welcome to our first C2450 static SI session. I'm your SI leader Hong, and today we're just going to do some example problems, some extra practice on the topics and concept that Dr. Okori already covered in the class. So today's our learning objective is going to be first learn how to write the force in Cartesian vectors form and how to find the resultant force in 2Ds. And we're also going to review the parallelogram law, and lastly, we're going to do one example problems on how to represent the force vector in 3Ds. So before we begin, I'm sure you guys are already familiar with this as the unit vector right here. The first is the international system, SI system, and the second one is the US cosmary system. And first, let's begin talk about what the parallelogram law is. So parallelogram law is basically that if you have two vectors, A and B, point to the direction, then if you want to find the resultant vector, which is A added to B, then the resultant vector is going to be somewhere in the middle. And then we can construct this. We can construct the system by using the parallelogram law, which is when the heads of A meets the tails of B, like B is parallel to A, and this is B, and same thing, the heads of B meets the tail of A, and then we can construct our triangle A, B, this R, or we can do it this way. This is R, this is A, and this is B. Okay, sorry guys, my drawings and handwriting is so horrible. Okay, so some important properties of parallelograms. So first, opposite sides are congruent, which is that AB is equal to DC, as we can see from this picture. AB and DC, their sides are congruent, which means that their sides are the same. And opposite angles are congruent. For example, D equal to B, like the angle right here and here are the same. Okay, and the consecutive angles are supplementary, which means that, oh, my bad. Which means that A plus D equal to 180, or B plus C equal to 180. So those are just some important stuff that you guys already know from geometry. So I'm not going to talk too much about it. But I do want to talk about what is law of sine and what is law of cosine and when to use them. So first, we use law of cosine when there's at least two sides are given and a angle between those two sides unknown. Right now, there's at least two sides are given and the angle between them is known. Okay, so this is a condition when we use law of cosine. At least two sides are known and we know the angle between those two sides. For example, if this is A and this is B, and then we must know this angle C right here in order to use the law of cosine. And on the other side, for law of sine, it's the opposite. So we use law of sine when there's at least two angles and a side unknown. Like this is a minimum condition. So when there's at least two angles and a side is known. Okay, so guys, this is just on the basic condition that we need to satisfy before we use law of cosine and law of sine. Okay, guys, so first let's begin with our first example problems. So the first problem says determine X and Y component of this 800-pound force. Okay, so let's first begin to find the angles. So first we know that, let me just show this. This is x-axis. First we know that this x and y-axis, they makes up a 90-degree angle right here. And if we know that this is 60 right here, then 90 subtract 60, that's 30 right here. Okay, so this is one way to find angle. And the other way is that if you look at here, here's x and here's y, and we know that this is 90-degree angle. So 90 minus 40, this is equal to 50. And right now we can actually construct our triangle. We can actually construct it in two different ways. First way is right here. If we know this is 40 and this must be 50, this is 90-degree angle. Or we can construct it right here. We know that this is 90 degree, this is 50, this must be 40. Okay, let me just write it out so it's clear for you guys to see. Okay, hope you guys can see it clearly. So right now we can find our x and y components. First, let's begin to find the y component. We know that this is going to be fy, this is fx. So let's begin by using this triangle. Let me use a different color. So Fy, we know that Fy is going to be that force 800 pounds times the cosine of 40. J hat just means that it's in the y direction. And we know that this is negative sign because the vector is pointing to this way. It's pointing this way. And from the system, we know that this is the positive x and positive y direction. So it's opposite from the positive y direction. So negative 800 cosine of 40. It's cosine because we know that y is conjacent to this 40-degree angle. And we can represent this fy in a different way. Let's say this is fy and fx. Then the alternative for this one would be, let me write this alternative, like if you are using this triangle for analysis. Alternative would be 800 sine of 50 j. Its sine, we know that since fy is right here and fy is the opposite to this 50-degree angle, so we know that this is sine. And from this, and if we plug this into the calculator, we are going to get, let me just put in the calculator really quick. This is going to be equal to negative 612.83 j hat. And don't forget the units, guys. It's in pounds. Okay, so let's begin find the fx. So for fx, we know that it's going to be the same 800-pound force times this angle. So it's going to be sine of 40. I hat just means it's in the x direction. Let me explain this really quick. So it's sine 40 because if we look at this triangle right here, fx is opposite to this 40-degree angle, so it's sine. And the alternative would be, and the alternative would be negative 800 cosine of 50. I have, and that's when you use this triangle for analysis. And let's plug this into our calculator. It's going to be equal to 514.23 I hat. pound. And then we're done with the problem, but we have to write this in the Cartesian vector form if we want to make it look prettier. So F equal to 514.23 I hat minus 612.83 J hat and their unit pound. So this is our answer. Okay, so pretty easy problem. And let's begin working on our second problem. The second problem says that determine the magnitude of the resultant force acting on the core belt and its direction, theta, measured from the counterclocks, y from x-axis. I'm gonna explain to you guys what does this mean. I'm gonna explain to you guys later after we work this problem. So first, it says determine the magnitude of the resultant force and its direction. So if we are asked to find the magnitude of the resultant force, the first thing we have to do is break each of these forces into their component, into the x and y component. So first, let's begin to break down F1 into their x and y component. So here's F1. If we construct a triangle, this will be 30 degrees. And we know that this is 90 degrees. And then this must be a 60 degree. 700 pound force. F1 x, that's going to be equal to negative 700 cosine 30 I hat. It's negative because we know that this is a positive y, positive direction. And this is our x, this is our y. The x is going to the negative x direction, so we know that this is negative 700 cosine 30. If we plug this into calculator, we're gonna get negative 606.22 I hat. Don't forget our units, pound. And F1y, same thing, 700, but this one is cosine of 30, J hat. Oh, my bad, 700 sine of 30. Because we know y is opposite of this 30 degree and x is adjacent to this 30 degree. So negative 700 sine of 30, that's going to be equal to 350 J hat pound force. Okay, so now we know, now we find our first force. Let's move on to our F2. Oh, just right here. F2. Oh, F2 is very simple. There's no component force acting on its x axis, so there's only one force. 400. Just that. So F2x is equal to 0. F2y is equal to 400. But guys, we have to pay attention to the direction. Since the positive y direction is pointing up and this F2 force is pointing down, so we know that this is negative 400 pound J hat pound force. This is simple. So let's move on to our third force, F3. If we construct the triangle, oh, see right here, they don't give you the answer, but they give you the 3, 4, 5 triangle. And let me show you guys how to do this. So after we construct our triangle, we can actually start to solve the problem. So this will be 600 pound force. And before we begin, I want you guys to know that the sign for this, since there's no angle given, the sign for this triangle right here is going to be 4 over 5. Because sine, we know that it's equal to opposite over the hypotenuse. Opposite is this 4, hypotenuse is this 5. And cosine is the same thing. 3 over 5. Because we know that cosine is equal to the adjacent over the hypotenuse. Adjacent hypotenuse. Since there's no angle given, we're gonna do it this way. But be careful, guys. If they give you a 3, 4, 5 triangle, and then after you find out the sine is equal to 4 over 5 and cosine equal to 3 over 5, in your calculator, do not input sine 4 over 5, cosine 3 over 5. That's a mistake. Don't do it. Because we already know that sine is equal to 4 over 5. So we don't have to input that sine to make it complicated. And this is wrong. Okay, so let's begin to find the f3x. So f3x is going to be equal to the 600-pound force times its cosine component, 3 over 5. And guys, as we know, this x is going to the positive x direction, so this is the positive 600, 3 over 5. And if we put this into a calculator, we're going to get 360 I had pound force. And f3y, be careful with is the direction. It's pointing downward, so it's going to be equal to negative 600, 4 over 5. And if we put this into a calculator, we're going to get negative 480 J hat pound force. And guys, and always I encourage you guys to like print out the worksheet or work this worksheet on your tablet or iPad or anything, so you can follow along. Okay, so right now we find all of our component forces for all of the forces. So right now we have to find the magnitude of the resultant force, and this is fairly easy. Use a different color. This is going to be, let's break down this resultant force Fr into Frx and Fry. So Frx, that's going to be equal to, we're going to add all of our x components. So first x component is this negative 606. So negative 606.22 plus the F2, that's 0, so we don't have to write it. And plus this F3x, 360. Make it clear, let me just write this 0 right here. And plus this 360. I have. And if we add this together, this is going to give us 242.66 I have pound force. You can always plug into your calculator to check if the if my numbers are correct. Sometimes I make mistakes. So now we find what Frx is. We have to find what Fry is. So Fry basically is simple. Add up all of y components. So negative 350 minus 400 minus 480 J hat. That's going to be equal to negative 1,230 J hat pound force. And then after we find out what Frx and Fry is, we can find a resultant by simply square them and take a square root of them. So negative 246.22 plus negative 1230. And then if we put this in the calculator, we're gonna get 1,254.40 pounds. So this is the question. This is the answer to the magnitude of the resultant force. And let me just write it right here so we can find the directions and the angle measured. Right here. Okay, so find the directions. So we know that direction measured from the counterclockwise. That's going to be equal to tangent inverse of Fy and Fx. That's because we know that if this is our angle theta, tangent inverse is going to be equal to opposite, which is y over x, opposite over adjacent. So from this, we know that this is going to equal to -1230 over -246.22. And our angle theta, that's equal to, let me put the calculator. That's 78.68. But this is not the direction measured from the counterclockwise from the x-axis, because this is in quadrant 3. As you guys already know, like this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Quadrant 1, we know that both x and y are positive. Quadrant 2, we know that the x is a negative, but y is positive. Quadrant 3, we know that both x and y are negative. In quadrant 4, we know that the x is positive, but y is negative. If we look at our fx and fy, we know that they are both negative. So they're in quadrant 3. So their angle is actually look like this. Measure it, look like this. So this 78.68 is actually just right here. So this is the measurement of this 78.68. And if we are asked to find the angle measured from the counterclockwise from the x-axis, then we have to add up this angle right here, which is 180 degrees. So our final answer is going to be theta equal to 78.68 plus 180. Then our theta is going to be equal to 258.68. And that is counterclockwise from positive x. I know, guys, this is a little bit messy, but I hope you guys can understand. Like, if you guys have any further questions, please just please don't be hesitate to email me.